Right, welcome back to the channel. Two more radios have appeared thanks to Dom. We have these, not seen these before. These are the Lancer. Now we've got a little logo in the middle of that there, I don't know if anyone recognises that, and a nice sort of dented grille, not a dented, but it's like creased down the middle, and it's I don't know if you can see that, it kind of goes in towards the centre. Push button on the side, PTT, and a rather unusual arrangement for the on-off switch. You see that? I can see why that probably didn't catch on, because that would be so easy to turn on, and if you just throw that in your bag and just it's on, isn't it? So yes, I can see why that didn't quite stay on. That's not, yeah, the UV5R hasn't got that, has it? So anyway, yeah, so Dom kindly sent me these, and you have noticed that one of them does have a broken antenna. Now, it's not the end of the world on these radios, these 9-volt radios. They will still work, even with the top section missing. You're not going to blow the output transistors up on these, I'm telling you now. I've over 30 years, I've never had that happen once. So, on these 9-volt ones. So, let's have a little look. Got a bit of tape on the bottom of this one. Perhaps we'll just, obviously, maybe have to do a repair on that. Now, like I say, Dom very kindly sent these in for free. So yeah, that's obviously going to need something doing to help that stay in there. And we do have a note. Look at that. It's like from Dom. Here we go. Screw missing on board. Case broken on the bottom. TXRX okay. PTT button dodgy. Non-original antenna tip. Oh, okay, yeah, it does look quite a big tip on that antenna, doesn't it? There. Okay, so that's a screw-in type. And we'll be able to sort the screw on the board, and it looks a very, very simple design, doesn't it? So is this one going to lift out? If there's, oh no, there is more than one screw. So let's just concentrate on this one for now, and we'll take the lid off of the back. We'll get a screwdriver. Yeah, this is super interesting. Look at how old these components are. These, I would say, looking at these, they're probably very early 60s going on the components. Crystal in a plastic can there, I've not seen that before. But you can tell by the old style of resistors there and the capacitors there in the cans. You don't see them like that anymore unless it's in old equipment. But they look really nice and vintage. And again, we'll make a call on this. You know, if these appear to work okay, I'm not going to go changing these vintage components, because these vintage components themselves, let me just turn that radio down, these vintage components themselves, you know, if the radio is working, to me, I prefer to keep the original components in, because if you look at this radio, 1, 2, 3, there are 3 fairly significant capacitors in there to change, and then you put in new capacitors in, and it's no longer, it's lost some of its vintageness, hasn't it? Look at that speaker as well, Pioneer with the brand on the back there. That's lovely. Good size. Look at the coil on that. It's a good size coil, isn't it, for a fairly small speaker? You don't see that. So I'm probably just going to pop some power onto this and just see how it receives, and see how it transmits, see what frequency it's on, and we'll just do a basic test on it like that. If these are really bad, I will change them, but they look so cool, and if it works, I'm just going to leave them in. You know, like I say, it's, you know, it's not a sort of radio you're going to use every day, and as long as it works, it works. So we shall just run some tests on them just to make sure they're okay, and as we always do, we'll go out in the field and give them a test. We'll give the PTT a little squeeze, just spray a little bit in there. And then we'll put a little bit on this rocker on-off switch as well. And sometimes it's also worth, with these battery leads, just having a look at them, see if there's any corrosion around there and cleaning that. I use a little fibre brush for doing that. Let's give that a good work in, make sure that's alright. And then we'll see what channel this is transmitting on. I can't see any evidence of what channel he didn't say what channel that they transmit on, but we will find out right now. Right, you can see when we transmit, we're on 27.060, and 27.060 is in between channel 8 and channel 9 on the US or the EU AM frequencies, so it's in betwixt It's neither or the other. So we will need to move that either up or down onto one of the bands to get that obviously spot on, which I'm sure we can adjust with something on the board. I'll have another look and see. Right, looking at the board, what have we got in terms of adjust around here? It's possible that could be adjust there. We've got our oscillator. Our oscillator circuit is going to be here, so we'll have a little play around. So I'll have a play around off camera with this, and we'll drag it down. We'll probably drag it up. Should we drag it up to channel 9? It's literally in between the two, so I'm pretty sure on this circuit we can take it where we want. So just pop the back off the other one, and we have some details. It's the model number RT33, crystal control transmit, 27.065 megacycles. That's an old word, isn't it? Transmitting power input 35 milliwatts. So there we go. Inspected, made in Japan, manufacturing date, whatever that number means. It's obviously something relevant to them. I can't quite see anything there. So there's the FCC sticker. Antenna, single element, 4 5/12 feet full length. That's what it says. This is a very long antenna for a very small radio. So we will need to move this up to channel 9, and we do have another note from Dom in this radio. Let's have a read. Lancer 27065, channel 9, frequency TXRX seems okay, circa 1960s. Antenna tip missing, circuit board bottom broken / repaired. Okay, so that's on this one, and it does indeed have a piece broken at the bottom, and it's been repaired. I don't know, we'll see how well it's been repaired. So let's see what this one is transmitting on. Yeah, this one is slightly down, 27.060. So whether we can get these up or not, I don't know. Onto frequency, there's only that one adjuster, that one inductor that you can see on the board. So now we know we're somewhere anyway. We can definitely. They sound nice and loud on the audio side. So I'm not even suspecting any of these old capacitors, to be honest. It sounds really loud, and they do look well made. So right, let's see if we can just up the frequency a bit. If we can't, they'll have to stay in betwixt the two channels. Slightly annoying, but at 35 milliwatts or less, I don't think that's going to be an issue for anybody around here. So okay, let's get the trimmer. Right, so we've got the TinySA generating the strongest signal it can off the antenna, off the side of it. I turn the radio on, and we can't hear it at all. So let's just see how that compares to the President Randy. Although the President Randy is going to be slightly off of frequency. But there you go. So President Randy's got the signal quite strong there, and that's not even on frequency. Obviously, it's off frequency. So yeah, these aren't going to be the most sensitive radios in the world because they're not even picking this up. But there you go. Right, there we go. We've got the TinySA sat on the bench next to the set, and we have the antennas quite close. And as we lower the antenna down there, you can see the signal increase and decrease as we move it away. So yeah, we are quite very unsensitive there. Right, before we go any further, what I'm going to do, you can see why this case falls off on this one. You can notice here the tab there on that one is intact, and this one is snapped off. So what I'm going to do is we're going to Dremel down this so it's completely at 90 degrees with the base of the case, and then I will 3D print another piece to go in there, and it looks like we're okay to, just glue it to the back as well, and we'll glue another piece of the case in there, and then hopefully that'll be enough to keep this lid on without having to use tape on the back of it. It'll just look a bit nicer. So I'm going to jump on the computer and we'll do that now. There we go. That's our repair. And they've even got the little angle on the back to match the angle on the back of the case. So hopefully that's going to stay okay, and if it's all good, then we'll paint it over some black paint and it'll look, well, pretty good. It'll look a lot better than it is. And there we go. It's not coming off there, it's nicely fixed on there. So the next thing to do, cosmetically, there's a tiny little chip in one of these, but I think on areas like that, that can, you know, that's just part of the radio's history. But the other antenna, I pulled a bit of sleeving off of there, and luckily there still is the thread. So if you can see that thread there, that's an M3 thread, believe it or not, an M3 fine thread. So I'm going to show you a little trick of what you can do, because obviously getting antenna tips just isn't a possibility. And what I'm going to attempt to do, this is my own little brainwave, I've not done this before, but you know those on those mirrors, bathroom mirrors, you see they have screws on the bathroom mirrors. Well, what they do is with those screws is they cover them with a little cap. Now, and it is actually metal. They say it's stainless, but it's never stainless, that is it. But it is metal anyway, nonetheless. And it's, you know, it's suitably shiny. There were some sort of aluminium ones. Now, of course, the problem you're first going to see is, well, there's no thread in there. But there will be, just shortly. I'll show you how I'm going to do that. So if we pop this, we've got to be a bit careful. We need to get the pliers on it. If we pop the antenna back in there, because I bought the right size, you can see there that when that antenna shuts down, we're going to have a nice cap on the top of the antenna that's going to look something like what it should do originally. The original, the cap that was on it is this one, which wasn't original. That isn't the original cap that goes on it. And when I said that thread was M3, it's actually M2. I actually got that wrong. So what I thought, these little brass inserts, which you may have seen me use before on the channel, we push into plastic, we heat them up and use them as a screw hole. I thought if we drop one of those in the centre of the cap there, we will have a nice receptacle for the thread on the antenna. And of course the other simple way of doing it is just to centre the nut in the actual fixing there and just pour epoxy in. Now I did this, I 3D printed a little clamp assembly to do this, whereby I screwed in the nut so it's held firmly on the back of the plate like such, like that, and then filled these full of glue, turned that over, dropped them in so they dropped and sat inside of the caps, and then just left them there. Then when they were hardening, just simply remove the screws and you get the captive nut held in with epoxy. You can see there it really is filled with epoxy right up to the top, and it's threaded the inside of this, so I can't see that coming out. So that's as good a way of doing it as any. There are a number of ways of doing it, and of course if you haven't got a threaded section, I was going to mention this, if there is no threaded section at the top of the antenna, there are different ways of doing it. You can kind of splay it and then just use it, but you're really only left with options for gluing if you've got no threads. But it is very tricky if there are no threads at the end of the antenna to do something that looks good, and is also, you know, it's up to the task, because when you look at this, you know, and look at doing this, it's not simple. There's quite a lot of force on the end of these little tips of the antennas on the radios, quite more than you think, and so whatever you do has to be a fairly robust thing to withstand the pulling and also the pushing. So if you've got like a washer or some sort of loose affair in there, it's not going to stand up to that kind of movement. People are quite rough with antennas, hence that's why they very often aren't there or broken on radios that you buy. So there we go. But that's, I think, a nice simple way of doing it. I think they look perfect. Let's see how they look on the radio. The tip of this antenna is broken a little bit, so this is bent, you can see there, but there we go. There. The antenna needs a clean as well, but looking good to me. Okay, right, we've got these two old handsets here. We're going to have a bit of a try. It's a nice day today. We've given the antennas a bit of a polish, so we'll do our usual test across the field and see how they perform. Just to give you some idea of how long the antenna is, there it is, look, right to the top. It's quite a long fella, isn't it? Yeah, so as I thought, sadly these are pretty poor with range. There's Tyler there. Do you want to give us a quick brown fox? There he is. Right, so Tyler reports that when I was in the middle of the field, he could hear me. I couldn't hear him very well, but he could hear me. So it looks like my radio is transmitting, and his is receiving, but this one isn't receiving and that one isn't transmitting. I think that's the problem we got with these. So what I'm going to do is I'm going to take them back to the bench, see if I can find out if I can improve these somehow. It might be those capacitors, and what we'll do is we'll come back out and do another test. So we've got the TinySA with its antenna out making a signal. We're back here in the shack, as you can tell. Now this is the radio that I was using, and that is Tyler's radio. So Tyler could hear me okay, but I couldn't hear him, so I think it's a receive problem. Because I'll just show you now. So we've got a tone coming out of the TinySA. You can barely hear it on there, it's very, very faint. And on this one, there you go, it's much better, isn't it? So what I need to do is see if we can improve things on this, and it might be capacitors on this. So I'm going to have a play around with this one to see if I can bring that in a little bit. Right, you can see how useful this is now. So that's about peak. Go back to there. I reckon that's about peak. What we'll do, turn that off. What we'll do, we'll actually listen to that signal on the synad meter, and we'll peak it on there. Right, that's a lot better now. There we go. And now the other one, you can tell, is actually worse. So that one, which is right next to it, needs tuning in. So I'll do it in the same way, and we'll pick that one on the synad meter, and then they're as good as they can be, I think, on receive. And then I'll just have a quick check on transmit, see if we're getting the same level of transmit power on the SDR, and if we are, I think that's good enough for another test. Right, so we've improved the receive on this one, but it does have this broken antenna socket problem. The antenna mounts to the board. It's obviously a point of where there's a bit of stress. So I'm going to try and fashion something up there. I don't think there's any circuit board in terms of copper there, but you can see there's a fair old piece of the board missing in terms of its structural strength. And we've got a little decoupling capacitor that's broken across the antenna there, so let's try and see what value that is, and we'll replace it on this radio. And this coil is coming apart. This is the loading coil for the antenna, so we'll get that sorted out. So do that off camera and then come back. Right, we've done a pretty solid repair on that. I think we've put a nice washer and an Allen bolt through that and glued the washer to the back of the PCB, so that's really not going anywhere. And just for safety, I've tacked it a little bit with a little bit of hot glue just onto the side of the antenna, just to stop it moving around. So hopefully that's going to be nice and sturdy. It's not going anywhere. We've put a new capacitor across the little loading coil there because that was missing, and yeah, hopefully we'll be having a bit more success with these now. Yeah, one of these orange capacitors is definitely bad. So there's me, Mr. Nostalgia. I wanted to change them. So in this one radio, I'll probably change them in both, but just for now I'm going to change them in one because that one's a duffer. Right, we'll pop back to the field with these tomorrow. In the end, I did change all the capacitors. As much as I like the look of them, there were some dodgy ones in there. And I also changed these modulating transistors as well. These are pretty old, very low gain. However, they are quite useful for people with these, I found out, with these fuzz pedals and things. So I'll pop those on eBay because they work, but they're just quite low gain. So I'll put some modern equivalents in, and that's really brought the gain up on these. But they're still really low powered walkie talkies. So you know, not a lot I can do about that. So, but they are working a lot better now than they were. I also had to put a new battery clip in one of them as well. So I can't spend any more time on these now. We're going to just go out into the field, and however they work, they work. Right, it's now a few days later. The weather has picked up. We'll come out to the same spot again. I don't think we're going to get much more range with these, but hopefully we'll get a little bit more, so we'll try again. Right, this is a lot better. Hi Tyler, wonder if you can hear me okay. Just give us a quick brown fox. Wow, that's loads better. I know he's only there, but if you wind the video back, you'll see it was pretty bad before. Oh, there we go, that's lots better, isn't it? Oh there Tyler, yeah, okay, I'm now halfway in the middle of the field.
Halfway in the middle of the field, I think we definitely improved these radios then. Do you want to give us the quick brown fox jumped over the lazy dog? The quick brown fox jumped over the lazy dog.
Wow, look at that. Wow, that's loads better. I'm going to go to the other side of the field now, mate. You can stop recording.
Okay.
There we go, he's right there at the other side of the field. Okay Tyler, right, this is your dad. We're now right over the other side.
So this is your dad. We're now right over the other side of the field with these hopefully nicely repaired sets. I wonder how I sound to you. The quick brown fox jumps over the lazy dog. The quick brown fox jumps over the lazy dog.
Okay, I'm just going to go a bit further and we'll try one more time. Okay, so if you can stop recording and I'll speak to you in a second. I think this is about the limit. We're right across the other side of the field. Oh, there he is. Hi Tyler, I think we've reached the limit of these radios. We're right across. Wow, that's
superb. Okay, mate, you can stop recording on there. Stop recording now and I'll speak to you later. Okay.
right. Wow, I think that's done superb. That made a big difference, didn't it? The changing out the transistor and the capacitors has really helped. It's made these go from being unusable to being completely usable. So I'm really pleased with that. So if you have been, thanks ever so much for watching. Have a great Easter. Hope you all have a good time, and we'll catch you on the next one. Take care.
Just A7, now